Before you pull up to that pump one more time, take a quick breath. Because the biggest threats to your car, your wallet, and your safety aren't always obvious. They hide in everyday routines that feel completely normal. These small oversights can quietly wreck components deep inside your fuel system, trigger expensive dashboard warnings, or worse, set the stage for a sudden blaze right where you're standing. The very last tip in this breakdown could spare you major repair bills or keep a bad situation from turning catastrophic. Stick around until the finish, since tons of drivers repeat these errors without a clue. We'll count them down from number 15, starting with a habit that's so instinctive most people never question it. Mistake number 15, hopping back inside your vehicle mid-refuel. You latch the handle open, walk away briefly, then slide back into the seat. Maybe to escape the chill, check messages, or adjust the heat. A minute later, you hop out and reach for the nozzle while fuel is still rushing in or has barely finished. On the surface, the hardware hasn't shifted. But electrically, you've created a serious hazard. U.S. fuel pumps, hoses, and nozzles are deliberately grounded to dissipate the static that naturally forms as gasoline races through the lines at high velocity. While your hand stays on the nozzle at the start, your body stays safely tied to that ground path. The instant you release it, shuffle across upholstery or carpet, and climb back in, friction generates a charge on you, sometimes thousands of volts. You become a walking spark waiting to happen. Gasoline vapors gather thickest right around the open filler neck, often hitting the ideal flammable mix. A tiny discharge is all it takes to ignite them. Fire codes across the country specifically prohibit re-entering your car during refueling for this exact reason. When these incidents occur, the blaze erupts instantly. Flames lick up the vehicle's side. The driver panics and yanks the nozzle free, spreading burning liquid everywhere. If you ever need to duck back inside, always make contact with unpainted metal on the car, far from the filler, first to bleed off the charge before touching the nozzle again. Static discharge is a real flashpoint risk, but the next error pulls that same danger straight into your trunk or bed. Mistake number 14. Keeping the portable fuel container inside your vehicle while filling it. You're grabbing extra gas for the mower, generator, or chainsaw, so you set the plastic jerry can right in the trunk on the cargo mat or in the pickup bed for convenience and start pumping. It seems secure and tidy. In truth, this ranks among the most hazardous moves at any station. Standard consumer cans are molded from high-density polyethylene, a superb insulator that traps static rather than letting it escape. As fuel sloshes and splashes inside, charge accumulates rapidly on the liquid surface and the can walls. On bare pavement, faint moisture helps the charge dissipate gradually. But on rubber mats, carpet, or plastic liners, the container floats electrically isolated. Voltage climbs until it arcs across the tiniest opening, usually right at the spout where vapor concentration peaks. Post-accident reviews of truck and SUV fires repeatedly point to the same setup. Plastic can plus insulated bed or trunk, plus low humidity. Spark at the rim. The safe approach is straightforward. Lift the can out, set it directly on the concrete or asphalt, and maintain constant metal-to-metal contact between the nozzle spout and the can rim throughout the fill. Never leave it elevated or insulated. Static risks lurk outside, but the following mistake invites trouble straight into your engine bay and hits your bank account hard. Mistake number 13. Forcing extra fuel after the initial automatic shutoff. The pump clicks once, signaling the tank is properly full. Yet you keep squeezing to hit an even dollar figure or chase a few more miles. In vehicles built for the U.S. market with modern evaporative emission, EVAP controls and onboard refueling vapor recovery, this overrides the system's precise design. The charcoal canister exists solely to trap vapors, not to handle liquid gasoline. When the tank reaches capacity, there's deliberate headspace for thermal expansion. Pushing more fuel after the click floods the filler neck, blocks the vent opening, and forces liquid backward into the vapor lines toward the canister. Once saturated, the charcoal loses its ability to absorb vapors effectively and behaves like a drenched filter. Vapor flow gets choked, the tank struggles to breathe, and you start seeing early shutoffs at every fill, fuel spitting back, persistent gas smells, and eventually EVAP-related check engine codes. Fixing a flooded canister, plus related valves and hoses, often costs $400 and $1,000 at a typical shop. The solution costs nothing. Respect the first click and walk away. Before we dive deeper, if you're finding these insights helpful for protecting your ride and avoiding surprise expenses, consider following for more practical breakdowns like this. Mistake number 12. Pulling in while, or right after, a fuel delivery truck is servicing the station. You arrive as the big tanker is pumping thousands of gallons underground, or you show up moments after it pulls away. Those enormous transfer rates violently churn the storage tanks, suspending decades of accumulated rust, silt, water droplets, and other debris throughout the volume. Normally, intake pipes draw from slightly above the absolute bottom, leaving sediment behind. But agitation turns the whole tank into a cloudy soup for a short window. Your pump immediately pulls this contaminated mix, overwhelming the inline filter sooner than normal. The electric fuel pump strains against the extra resistance, while finer particles sneak past to clog injector screens and disrupt spray patterns. The result? Rough idle, hesitation under load, occasional misfires, and reduced efficiency that lingers long after that fill-up. Spot a tanker truck on site or freshly disturbed manhole covers. Drive on and return in 20-45 minutes when everything is settled. Smooth, clean fuel comes from undisturbed tanks. Mistake number 11. Making a habit of stretching fuel down to near empty before refilling. The gauge hovers below a quarter, the low fuel light flickers on, and you push it just one more trip. On the majority of contemporary U.S. market cars, the in-tank electric fuel pump depends on surrounding gasoline for essential cooling and lubrication. Very low levels expose more of the pump motor to hot tank vapors instead of liquid, causing repeated overheating cycles that degrade bearings, windings, and seals over time. Low fuel also increases the chance of cavitation, brief air ingestion that leads to sputtering, stumbling acceleration, or sudden stalls. Worse, sediment, rust flakes, and hose particles naturally settle at the tank floor. Near-empty conditions concentrate that debris right where the pickup strainer sits, pulling it straight into the system. Refill consistently around the 141-3 mark to keep the pump submerged, cooled, and shielded from the worst crud. Constantly running near fumes shortens pump life dramatically and invites avoidable breakdowns. Mistake number 10. Keeping the engine idling throughout the entire refueling process. You roll up, leave the motor running to maintain cabin temperature, and start pumping. It feels practical, especially in extreme weather. But you're fueling while every electrical circuit remains live. Spark plugs firing constantly, alternator spinning, fans potentially kicking on, relays clicking. Hot exhaust components sit nearby, and gasoline vapors, denser than air, can pool low around the filler and under the chassis. In most scenarios, concentrations stay too lean to ignite. Safety regulations, however, account for the rare alignment of factors: a small spill, wind directing vapors toward heat, or a minor electrical arc coinciding perfectly. Meanwhile, the active EVAP purge valve cycles, drawing canister vapors into the intake. The engine computer monitors fuel level and pressure, expecting gradual changes from consumption, not abrupt jumps from refueling. Some models flag anomalies and adapt poorly, skewing long-term trims. Shut the engine off completely. A brief discomfort in the cabin is far safer than risking ignition or ECU confusion. Mistake number 9. Dumping months-old gasoline from a storage can straight into your tank before topping off. That half-forgotten jerry can in the garage or shed, maybe leftover from last season's mower or storm prep, gets poured in entirely, then fresh pump gas added on top. U.S. pump gasoline is a precise cocktail: light ends for easy starting, heavier fractions for energy, built-in detergents, and frequently ethanol, all tuned for clean burn, emissions compliance, and knock resistance. But time, heat, air exposure, especially in vented cans, and oxidation change everything. Volatile lighter components escape first, dropping octane by 3 to 4 points or more according to lab analyses. Oxidation creates sticky gums and varnish-like residues. Ethanol-heavy blends pull in atmospheric moisture, worsening separation and degradation. The worst contamination often hides in the bottom layers of the old can. The last ounces you dump carry the highest gum load and sediment. Modern knock sensors and ECUs detect the lower octane and retard timing to prevent detonation, robbing power and making the car feel flat and unresponsive. Those gummy byproducts coat injector nozzles, intake valves, fuel pressure regulators, and pump internals, leading to uneven spray, carbon buildup, and eventual misfires or hard starts. Don't treat your tank like a disposal site. Old fuel belongs at a local hazardous waste drop-off. Mixing it dilutes nothing. It just spreads accelerated wear throughout the system. Mistake number 8. Always gravitating toward the cheapest station or the least used pump. You spot the lowest price sign or the isolated pump with no weight and pull right in. Underground tanks everywhere collect water condensation, rust particles, and sediment buildup over years. High-traffic stations see constant turnover. Fresh deliveries mix and dilute contaminants, while busy pumps flush lines regularly. Low-volume or off-brand spots often sit with the same fuel batch longer, allowing water to stratify into layers, microbes to thrive at the fuel-water boundary, creating acidic sludge, and slow oxidation to degrade quality further. That degraded or dirty fuel hits your filter sooner, strains the in-tank pump, clogs finer screens, and distorts injector patterns. You might notice immediate rough running, hesitation on acceleration, reduced power, or even stalling right after the fill. Over time, clogged filters and fouled injectors become routine, and severe cases lead to pump failure or no-start scenarios. Prioritize busy, well-maintained stations with high customer flow and clean appearance. Quiet pumps are sometimes quiet for a reason. Savvy drivers have learned to avoid them. Mistake number 7. Grabbing any random container instead of a certified fuel jug. Stranded vehicle, empty generator, or quick lawn job, you reach for a soda bottle, old water jug, household bucket, or whatever's handy to haul a few gallons. U.S.-approved fuel containers use specialized HDPE or metal formulations resistant to gasoline solvent action, with low vapor permeation and proper venting. Everyday plastics soften, swell, crack, or leach chemicals, dyes, and microscopic plastic particles when exposed to fuel. Those fragments bypass the tank's coarse strainer, travel to the filter, and, worse, reach high-pressure direct injection components operating at 2,000+ bar with tolerances under 5 microns. The outcome? Prematurely blocked filters, whining or straining fuel pumps, fouled injectors with uneven spray, reduced power, and accelerated wear on precision parts. One certified can eliminates this risk category entirely. Improvised vessels deliver invisible contamination that only reveals itself after serious damage has started. Mistake number 6. Dumping fuel system additives into a nearly empty tank right before refueling. You add an injector cleaner, stabilizer, or octane booster to a low tank, then blast in fresh fuel at high flow rate. Additives are formulated to mix evenly across a full tank's volume for safe dilution. Concentrating them in a small amount of remaining fuel creates an overly potent solution that gets aggressively agitated during fill-up, with vapors and droplets potentially migrating into EVAP vent paths. The charcoal canister, meant only for hydrocarbon vapors, ends up loaded with excess chemicals it can't handle properly. Heavy solvent levels can also reduce fuel lubricity, subtly increasing wear on pump bearings and components over repeated uses. Bottle instructions specify 1 treat per full tank for good reason. Follow them to avoid turning a helpful product into a source of canister saturation and long-term issues. Mistake number 5. Repeatedly ignoring the manufacturer's recommended fuel grade. The door jamb sticker or owner's manual calls for premium, 9193 octane, but you default to regular to save money. Or casually run high ethanol blends in non-flex fuel vehicles. Octane measures knock resistance. High compression, turbo, or advanced timing engines are built around a specific minimum. Lower octane allows pre-ignition under load, triggering knock sensors to retard timing conservatively. The car never pings audibly, but it feels softer, uses more fuel, and shifts peak combustion pressure later, sending extra heat out the exhaust instead of turning it into power. Over thousands of miles, elevated exhaust temperatures accelerate catalytic converter aging, turbo housing heat soak, and valve wear. What starts as pennies saved per gallon quietly taxes expensive downstream parts. Stick to the specified grade. The small upcharge protects far costlier components. Mistake number 4. Drilling holes in the gas cap or tampering with the filler neck for faster filling. Constant early shutoffs frustrate you, so you modify the cap with a vent hole or bypass a rollover valve to speed things up. It works short-term, but refueling depends on balanced vapor escape through the EVAP system. Clogged vents or saturated canisters restrict outflow, causing pressure buildup and nozzle trips. Bypassing defeats that balance, vents raw vapors to atmosphere, risking codes and environmental issues, and opens the tank to moisture, dirt ingress, and pressure swings. True fixes involve diagnosing and repairing vent solenoids, hoses, or the canister, not hacking emissions controls meant to safeguard the tank and planet. Mistake number 3. Twisting open the gas cap when the surrounding area is filthy with dirt, mud, or sand. Road grime, salt, beach sand, or off-road dust cakes the fuel door lip. You open it anyway, dislodging particles that tumble directly into the filler neck. The flap or restrictor catches bigger chunks, but fine silt and abrasives hitch a ride with incoming fuel. Tank sloshing circulates them, overwhelming micron-rated filters and reaching injector clearances under 5 microns. A single road salt grain, 100 microns, or even smaller debris erodes pump impellers and injector internals over time. Short-term signs include faster filter loading, power loss under load, acceleration stumble, or noisy pump. A quick wipe with a clean rag around the cap before opening prevents hundreds in filter pump costs and thousands in injector replacements. Mistake number 2. Ignoring repeated early pump shutoffs and forcing more fuel anyway. The nozzle clicks off prematurely, flow stutters, or it only works if held awkwardly, yet you persist by feathering, restarting, or angling the handle. The auto shutoff senses vapor disruption at the tip, tied to your EVAP venting. Saturated canisters, kinked lines, or stuck valves restrict escape, building pressure that trips the mechanism early. Forcing liquid past that floods vapor-only lines, soaks the charcoal, turning it to ineffective sludge, and worsens venting problems in a vicious cycle. Test another pump first to exclude station faults. Persistent issues point to your EVAP needing attention. Pushing through escalates canister damage and future repair complexity. And the number 1 mistake that triggers more unnecessary repairs than almost anything else: failing to tighten the gas cap fully after every fill-up. You spin it on loosely, cross-thread it, or stop after 1 click instead of 3 or more. The EVAP system seals the tank near airtight and runs periodic pressure vacuum self-tests via purge, vent valves, and pressure sensors. A loose cap equals a massive leak. Vapors escape, defeating emission controls. Humid air enters, condensing moisture that promotes rust and corrosion in the neck tank. And dust grime cycles in out with temperature swings. The ECU detects rapid pressure loss, logs EVP leak codes, often P0455 or P0442, and illuminates the check engine light. Owners chase purge valves, vent solenoids, or full canisters, costly parts, before realizing the cap was the culprit. Always tighten until it ratchets at least 3 solid clicks. That confirms the seal is engaged and prevents vapor escape, moisture intrusion, and endless diagnostic headaches. Master these refueling habits and you'll shield your fuel system, avoid phantom codes, and keep expensive components lasting longer. But even perfect technique can't overcome consistently poor fuel quality. In the next breakdown, we'll expose the brands quietly wrecking pumps, injectors, and cats, and highlight the reliable ones that actually help your engine stay clean and strong. Stay informed out there.